This level requires us to move the crane to the tire position, pick it up and drop it back at the crane's original position. To find the tire position, we need to look into this guy, which is the data exchange control center. This data exchange control center contain uh, instruction sets which are a bunch of values, and only one of them is the correct value that indicates the tire position. So let me guide you through my thought process. By the way, you can find this code in the description below. Um, so, like I said, this data exchange control center contains a bunch of values that indicates instruction for the crane. Only one of those values is the correct one. And to find this correct values, we need to find the value that contains the exact amount of left and right and the exact amount of forward and backward, which is what this description here explains. So here, if we print all the data in this instruction set, we can see it's gonna be very hard for us to find the actual value that has a same amount of left, right, and forward and backward, because this data set is just huge. So here's the code. So first, of course, we connect to the sim environment, import the library, and define the only two variable that we need, which is the crane and the data exchange center. So here, to retrieve the tire location, I went for this code, which you can find here, which is basically getting all the data in this data set, right? So the data set is instruction sets in this dictionary, right? So I'm getting all the data from this object, which is the data exchange control center. And I'm doing a for loop for each values contained in this instruction set. I want the b, which is the backward command, to be the amount of b's to be the exact same amount for f, and the amount for right to be the exact same to left, right? Because when we're moving the crane, let's say this command goes backward, 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 forward, right, right, right. We want it at some point to pick up the tire and go back to the same original position. So same amount of backward and forward and same amount of right and left. Um, so let's go with that, because I set a command here to print it. And here we can see, oh sorry, well, sorry, I didn't mean to do that. So we'll just go back to it. So here, just go. and actually stop it at the right time. Does it stop? It does. Okay. I just had to do a little cut to reset the level because it was printing two different levels, which is not supposed to happen. It's a bug for this level. So here we have this only one value in the set that has the same amount of B and F and the same amount of left and right. So from there, I can get the tire position and set its target location, the crane's target location, to go pick up the tire. Um, so here, every command, so let's do BB, means backward 2 units. So each uh, command is equivalent to 1 unit in game. So here, the crane coordinate, which for some reason in this game the X is vertical and the Y is horizontal. If you want to go backwards 1 unit, you'd go on the x-axis -1, right? If you want to go right, you want to go on the y-axis right, and same goes for the other two directions. So here, since I have the tire location here, I just split it where we find P. So in this case, P is here, right? Because the command says go to the tire location, pick it up, and then bring it back to the original. Um, I'm going to split and just get the first half because I already know that the original position is at 0, 0, 0. So here, crane set target location, which is crane, the variable we defined earlier, which is this object. Commanded to go to this location, which is the tire location variable here, split in half already, right? So we only get the first half. The first half, we want to count how many F are in it, right? So F forward minus how many B's are in it backwards, right? Um, and same goes for the right and left. Right, positive direction, left, negative direction. So here's why there's the minus. And the Z value, which is 0.2, which is the Z coordinate right there. So the crane will go to this location first, sleep the program for 4 seconds, so it has time to arrive there. Command it to pick it up, set the location back to 0, 0, 0.2, right? Original position. Sleep it 3 seconds so it has time to arrive there, and release it. And normally, this should be it. Of course, I'm gonna reset it. Wait for the tire to spawn because it tends to give multiple values in this data set, which is not supposed to happen. So here it is. I hope you found that useful.